हरि करना।
Now let's one easy and effective way to estimate the sampling distribution of a statistic or of model parameters is to draw the additional samples with replacement from the sample itself and recalculate the statistic or model for each resample. So this procedure is called the bootstrap, and it does not necessarily involve any assumptions about the data or the sample statistic being normally distributed. So in this we have two important key terms for the bootstrap. One is bootstrap sample. A sample taken with the replacement from the observed data set is called a bootstrap sample. Nothing with replacement. The key word to be remembered is with replacement. Till now, whatever the sample we have taken, are all are without replacement. Now the bootstrap came into the picture to stress on with a replacement. So resampling, the process of taking repeated samples from the observed data, includes both bootstrap and permutation procedures. That's called a resampling. Let's conceptually look into this. So you can imagine the bootstrap as replicating the original sample thousands or millions of times, so that you have a hypothetical population that embodies all the knowledge from your original sample. It's just larger. You can you can then draw samples from this hypothetical population for the purpose of estimating a sampling distribution that you can see on the screen here. You see that this is our original sample, and then this sample replicated a huge number of times, and after that we can draw lots of samples, lots of resamples. Sorry, we should call them as a resample. Then we can draw lots of resamples from the sample, from this one, from this section. Okay, so now in practice it is not necessary to actually replicate. Let me put it this one as a bootstrap. Yeah. So in practice, it is not necessary to actually replicate the sample a huge number of times. We simply replace each observation after each draw. That is, we sample with a replacement. In this way, we effectively create an infinite population in which the probability of an element being drawn remains unchanged from draw to draw. The algorithm for a bootstrap resampling of the mean for a sample of size n as follows this way. So step 1, let's draw a sample value. Let's draw a sample value, then record it, and then replace it. Then step 2, repeat n times. Then step 3, record the mean of the n resampled values. Resample. Record the mean of the n resampled values. And step 4, repeat steps 1 to 3 r times. How many times, that we'll see. Then step 5, use the R results too, and calculate once using all are these once you using all these R results, we can calculate their standard deviation. So let me put it as sub steps. So let me go up. Yeah. Then here calculate their standard deviation. This estimates sample mean standard error. This estimates sample mean standard error to produce a histogram or box plot. 3. Find a very important one. Find a confidence interval. So here R is the number of iterations. R is the number of iterations of the bootstrap. R is the number of iterations of the bootstrap. So R is the number of iterations of bootstrap is set somewhat arbitrarily. The more iterations you do, the more accurate the estimate of the standard error or the confidence interval. The result from this procedure is a bootstrap set of sample statistics or estimated model parameters, which you can then examine to see how variable they are. So now let's understand this much simpler way with the example. So let's say a researcher wants to estimate. So example, let's say a researcher wants to estimate the average height of all the people in a city. Okay, that's what is target. But they only have a small sample of 20 individuals. So constraint is only they have only a small sample of 20 individuals. Okay, so now the researcher can use the bootstrap method to estimate the variability of the sample mean and construct a confidence interval for the population mean. How can he do that? He has to use the bootstrap method. Okay, first what he will do, first the researcher, the step 1, the researcher resamples the original sample with a replacement to create 1000 bootstrap samples of size 20. That's it. He has the original sample. So that's what our first step. Draw a sample value. We have this. The researcher has his original sample. So the researcher resamples the original sample with the replacement to create 1000 bootstrap, we call them as a bootstrap samples. We have just discussed bootstrap samples of size 20. We call them as a bootstrap sample. You see that? Yeah, size 20 individuals. Then the researcher can now, once he has done this, the researcher calculates the sample mean. Step 2, the researcher calculates the sample mean. The distribution of the distribution of the 1,000 bootstrap sample means approximates the sampling distribution of the sample mean. That's it. So the distribution of the 1,000 bootstrap sample means approximate the sampling distribution of the sample mean. So from this distribution, that's it, we got our sampling distribution. So whatever we want to make, that is there now. From this sampling distribution, the researcher can calculate. Then step 3, from this sampling distribution, the researcher can calculate a 95% confidence interval for the population mean height. For example, if the 2.5th and 97.5th percentiles of the bootstrap distributions are 165 and 175 centimeter, so 2.5th percentile is equal to 165 centimeter and 97.5th percentile is equal to 175 centimeter. So one respectively, then the researcher can be 95% confidence that the true population mean height falls within this interval, within this. So then the researcher can be 95% confident that the true population mean height falls within 165 centimeter and 175 centimeter respectively. 165 centimeters and 175 centimeters in this interval. So the bootstrap method is useful because it allows the researcher to estimate the variability of the sample mean and construct a confidence interval of the population mean even when the population distribution is unknown or difficult to model. I'm repeating this again because this one small sentence will explain the whole bootstrap method. The bootstrap method is useful because it allows the researcher to estimate the variability of the sample mean and construct a confidence interval for the population mean even when the population distribution is unknown or difficult to model.